Railway Civil Engineers Association. Welcome to Manchester. This is our last event for 2023-24 season. I'm Steve McCormick, chairman of the Railway Civil Engineers Association. I'm also a principal engineer for Network Rail, working on Transpennine route upgrade. We've had some issues with regarding to getting this event, not just IT ones, in terms of dates and venues. We've been trying to get this meeting for some time now, but little sort of issues like
just clicking your slides and see
slide, yeah. And again. There we go. Yeah, we've had a few issues trying to get this thing online. There was a thing called the blockade, which I think had people running around, and I contacted a few people. I was told to go away, but that all went ahead. I believe it was successful. Slide.
to move through at the same pace.
So just a little bit about the RCAA. We were formed in 1921. Exists to encourage the exchange of knowledge and experience between railway civil engineers. In 1997, following privatisation of British Rail, RCA became a specialist knowledge society of the ICE. Closely with other engineering disciplines through the railway engineering forum and the young railway professionals. Currently, we've got about 400 members, or just over now. Got a programme of 10 events a year held between Great George Street and here. Well, here, I say here in the region. We've also started doing some lunch and learn sessions as well, which is a new thing that we've started doing. There's the site where you can find us. Slide on. Oh yeah, you're okay. Membership, we've got all in Irish, 1850 a year, retired 550. Federal 875 and leading members of the IC is free. Next slide. Fancy getting involved? You can join us a committee. We generally meet once a month. Our next meeting is in September on the 24th, 5 PM for 1 hour. You have it online. We look at discussing future events and the direction of the RCA. The details there, but if you are interested, just send an email or contact me. So tonight's events, Hope Valley Railway Party Upgrade. I can speak with a little bit of authority on this. I was involved in this on the early days, and extremely difficult job. Presentation will be highlighting the challenges, the solutions of this multi-million-pound project, which was substantially completed spring 2024. And I think the picture on the right there is the first train that went through Dore and Totley station. The project consists of following major improvements: extended platforms and new platforms with accessible footbridges and lift towards Totley station. New passing loop between Bamford and Hathersage, and all the extensions to the infrastructure that the extra line. New footbridge at Hathersage West to replace the current crossing to improve safety. A significant amount of signalling improvements and line speed improvements and journey time improvements throughout the length. Speakers. Jamie Walker, head of engineering for Stories, or Story Contracting, I should call you. He's worked with Story Contracting for over 20 years. He's accountable for the delivery of engineering compliance for all railway projects in England region. Jamie was heavily involved at the start of the Hope Valley project, and as I said, Jamie and I worked together in the early days in this project. Jamie is also responsible for design and engineering management on NW earthworks, structures and property schemes within the work bank, together with other tendered and awarded works. Our second speaker is Dominic Mills, Senior Project Engineer, CREC for Dore Contracting. Dominic has 9 years construction rail experience in project engineering and contractor management. Dominic was in September 2022, where he was employed on the Hope Valley project as the CRE construction and temporary works coordinator. Prior to joining Dore Constructing, Dominic worked for Transport for Greater Manchester for 2.5 years as project engineering lead and designated project engineer for renewals and framework projects. If you're here, you'll actually see that there's actually only 2 speakers present. Unfortunately, Tom can't make it. He's put the slides together, and I think Jason will be delivering.
More where Tom's at later.
Yeah. Tom again was heavily involved on Hope Valley. Joined about the same time as yourself, is that right?
Well,
yeah. Being project engineer, undertook the roles of CREC and temporary works. So imagine what geographically you covered different areas, do you?
Yeah, initially I covered the workload.
Yeah. So Tom was involved with the bridges, culvert extension, soil nailing reinforcement, cutting works, station upgrade scheme, including the access for all Footbridge, and the new platform extension. Prior to Dore Contracting, Tom worked for Morgan Sindall for 7 years, working on the Past Tunnel North Pole project, the Warrington Grade operation, and Hatton Road North Junction power improvements projects. So that's the introductions over. I'm going to hand over to Jamie.
Back in social.
Yeah, see the moon and the
Forward. Yeah, so that's the line we can see there, right? So, right. Everybody, good afternoon. Apologies again for the IT, which is getting up and running. Notoriously bad. Wi-Fi is a little bit slow, so thanks, Steve, for the introduction. Like I say, my name is Jamie Walker, engineer for Dore Contracting. In the early stages, I was heavily involved in the, well, still am quite heavily involved in the Hope Valley project. So I'm going to take you through a bit of an introduction, and then Dominic and Tom, so I'll get to in a moment, take you through the detail of the jobs they've been delivering on the scheme, and then we'll do a little bit of a roundup. So onto the overview of the agenda we're going to go through. Steve's already covered the introductions, past that one. We'll have a look at what the delivery team's made up of. Then we'll go through just what the job is, what it's trying to achieve. Then we'll look in a little bit more detail at the civils intervention. Yeah, we'll go into all the narrative on there again, but some of the photos to quite be on the end there, and in the middle looks quite surprised to have his photo taken. Tom was going to be with us tonight, but he came pleading leave had in hand, saying that he'd been selected to do the fishing and international competition in Spain this weekend. So really turn him down. So he's put the material together, and I'm going to valiantly attempt to try and present that for Tom. So if we move on to the team, the delivery team, so right at the top of the tree there's obviously Network Rail, and the Volker Rail there on the left-hand side, and Story, then we came together to form that JV. So that's the delivery team. Then we've got our supply chain partners there. There was dozens, obviously, but some of the key ones we looked at as part of the initial stage of the Richter, Temporary Works, Mark McDonald in the design, Alstom in there for the signalling, and ECAS, who are our environmental consultant on the job. Timeline as to how the job's come into evolution. So you see there, we're back in June 2019. That's where both Vulcan and Land Story were tracking the Hope Valley Capacity Improvement Project. We sort of both had our eye on the job of that page at that time rather. Vulcan Story got together, decided we got to tender it together, working with Mott McDonald on the DAV at that time. Invitation came out January 2020, went back in April 2020. Got the bad news that we'd actually been awarded the job around about December 2020. Then when it stand down, there was sort of mobilisation, pre-works, GI and so forth. 21. Then we actually hit the ground running, really speaking, doing the physical works around about 2021 in December there. So there's that nice long gap in the middle there. So we geared up to the main commissioning blockade, which will be some of the output of that in the later slides, around about March 24. And then we've got that planned project completion date of September 24. But as with any project, the challenges on that, which we will come to as well. But the bubbles there that give the main thrust of what the Hope Valley project is all about. Faster, more reliable journey times for passengers first, buzzwords, what have you. Improved connectivity between the two major conurbations in Manchester and Sheffield, because I think that line is notoriously slow, clunky and so forth. And the upgraded network to meet the future demand, which is part of the future proofing for the line as well. So, brief outline of the scope. So new track platforms at Dore and Totley, passing loop at Bamford and Hathersage, new footbridge at Hathersage, signal improvements right the way through, but we're not touching on any signal improvements or the track stuff in this presentation. We're mainly dealing with the major civils interventions that we put in place to deliver the scheme. And another slide that shows the timeline. Now, John Lee, I'm going to have to ask you, the next slide has got an embedded video in it. I'll keep an eye on Steve's laptop to see if you can get it to run, but if you move on to the next slide and see if your IT is good enough to actually run it. I don't think I'll be able to run it from here, but I'll have a go. Yeah, the video is running on the online version, guys. I'm afraid it's not running on our presentation here. So what I'm going to do, well, that's running there. I'm just going to unshare on here so I can move to the next slide so I don't get the glitch. Yeah, I've got it on the line, so yeah. If there's actual soundtrack behind that as well, I'm not sure if apologies for that again, guys, if it's not coming through as intended, but say we've got challenges there on the IT, both at this end and online. What was there is just the scope of the project that goes through to Stockport and centering through into the major intervention area we're going to be talking around at Dore and Totley station, in the Dore Triangle as we call it, then over at Bamford. I think if that video is finished, if you can just try to get onto the next slide, that would be good. And we're back on the same page. So once again, apologies for the glitches in IT there, but we're back up and running now, just with straight animated slides all the way through to the end. So first area we're going to be talking about is where the Bamford Loop intervention works are. So main thrust of what we were doing here, there'll be more detail to follow, but we built, I think it was approximately about 1,200 metres of a pass loop that was built just to the east of Bamford Station. Shooting from the room here to well, just there to provide a passing loop. A number of things that we have to do in there: culvert extensions, cutting that we have to widen, put the new track bed in, and then embankment widening, put the structures. And down the bottom end there, this was some improvement works to remove a local user foot crossing and provide a new footbridge. On to the works down at Dore and Totley station, or rather Dore and Totley, you should call it. So again, on the left-hand side of the slide, you can see there, that's the Dore South curve cutting. So we've got some further earthwork stabilisation to do there, which we'll come to. Right in the middle, there's Dore and Totley station, and the main thrust of this work was to redouble Dore and Totley station, build another platform and an A-phase scheme, and then the track was obviously doubled right the way through onto the Dore South curve. So we had some bridge intervention works to do there to provide the space for that new track bed. The three main bridges, TJC 134, 35, 36, which Dominic will touch on in his slides. So coming to some of the challenges that we had on this project as we go through. First one, this was all delivered under a Transport Works Act order. So without teaching anybody to suck eggs on this, it's like the glorified planning that had to be gone through. I think what's worthy of note on this is the dates that are on the bottom. It came into Act Minute Force 2018. That means the poor ladies and gentlemen that were working on what the Transport and Works Act order included probably had no idea what we're going to be delivering and the scale that we were at. So by the time this Act was issued, we were been constrained by the conditions within this Act. So that's boundaries, land access, ecology, stakeholders. There's a myriad of different things that were encapsulated within this order that the whole of the project team were then bound by. So as we go through, we'll probably think back to this DWA or here as the challenge created. Over 36 initial objections during the consultancy phase. 70 stakeholders that we had to manage throughout the project. 15 different landowners involved. So our team that were in a consent, ecology, so forth, we're busy right the way throughout this project. Not only keeping the project team in line with what we were doing, but also managing those stakeholders. And that's not just the ones that were included in the TWA. There's loads of outreaches that we did with schools, STEM events, volunteering and so forth. So the guys and girls that were in that team were busy as the project guys that were actually doing the interventions on the ground. Coupled up with all this is minimum viable product. So everyone was a prisoner on this job. It had a budget. So you'll see from some of the intervention and even some of the things that we had to explain to the guys on the ground. Why are we doing this and not doing that? Every pound prison, and we only did the minimum requirements to meet the requirements of the project. There's loads of work that we could have done in and around the area, but as we say, very tight on budget to deliver this. So this was the round way through it. What the project is. So I'm going to hand over to Dom now, who's going to take you through the first phases of some of the works that we delivered.
I'm Dom Mills, Senior Project Engineer, TREC and TWC, initially get the whole project from the deliverables aspect, but end up splitting it on just with the workload basically. Jamie's already been through this, these interventions that I'll be running through down the Dore and Totley end of the job. In chronological order, Bridge 34, quite straightforward in the context of this project. It was a waterproof installation, so track off and on. Bridge 35, which was the next one along, it was a bridge renewal and track reinstatement. Precast concrete, so 8 beams that were stitched together on site, as shown on the bottom right there. We installed Christmas blockades that I was using a Kirov 1200 frame. Just run through some of the challenges we had on site. So underneath the bridge there was a confined space. So one of our challenges was trying to lift the bridge deck out without anyone going underneath. What we landed on was burning holes through the bridge deck. So up to about half a metre, so you could pass it from one end to the other, back up, then use the 20-ton spreader beam, pull the bridge out into sections. Another challenge was, because we're doing this at Christmas time, you've got the risk of weather. Luckily, when we installed this, it didn't get below about 7 or 8 degrees. As part of all the contingency planning, we had to make sure we had plans for anything down to about -5. So we ended up getting the lab to test the route down to -5 and tested it multiple different products, so we knew that it would perform. because we had a time constraint. So I believe it was 15 newtons before we could load it up with any plant machinery, and we had to do more start to finish. So we had provision there for heating up the grout, heating up water. You see the permanent form we there, keep the heat in, get weather out. Another challenge was just the logistics of getting materials from the site. So all the bridge segments, the steel beams were stored in the station car park, picked up by a telehandler, brought it out to the track. Kieran was sitting there, hooked it up, and drove it down about 150 metres down, install, come back, because there was nowhere to store, or very little room for raw materials. You see where the sleepers are there. It's about the only room we had for storing materials. And in Christmas position, there was a lot of work that went into contingency planning. So we had lots of stop, no go points. So one of the contingencies is, you see there on the bottom right, if we had to do, we couldn't get the bridge segments down in time, so the crane broke down. We couldn't actually get the bridge to side to backfill it. It's type 1 in layers on and using the spare drainage pipes we had on the project to allow the culvert water to flow. Image on the left there, looking at options of specific tension, because when we dug for the bridge, we're going to be in the track support zone of the adjacent track. Another contingency that we looked at was just keeping only installing segments and opening up the track on the left, because that's where the live traffic was. Track on the right of that image is the new line wasn't operational. After, as with some of these, looks the same as we did before in a lot of ways. So 6, next one along. So this is a standard network rail U deck, 76 ton, 50 degree skew, 13 metre effective span. Concrete was poured in factory, and yeah, you see the concrete sill beams underneath it as well. The challenge for this was the install. Because of the location of where it was, we couldn't get any road paints in there or anything anywhere near it. I'll show you a slide a bit further that explains it. So the methodology we landed on was a tandem lift for 2 rail mounted cranes. And doing that, so we had the bridge come in via road into the Dore and Totley station car park. We had to get it close enough to the track that the 2 cranes could lift it off. Had the 2 cranes had to go in swivel mode to reduce the tail swing, which meant we had to get the bridge within 5 metres of the track. We had one go at this and didn't go right. So second time around, a lot more planning went into to remove fences, prepare the area, everything set out exactly where the bridge needed it. So there was a bit of a learning there between lift planning and temporary works to make sure it all lined up. So we even went to the extent of doing a sweat path analysis through the car to make sure the bridge getting backed in was going to hit any light or anything else in between. You see the proximity signals there. That's where the issues with tails on the crane itself. Outrigger mats that were made and loaded up. We had cable running underneath there too, signaling cable and everything. On the top left there, that's the pad that we built. So we took the fence out, took the curbs out, built the pad there, bridge cables, got the levels right, and then the wooden prop in there showing so that the bridge could turn up to site with the bearings installed. So the way the bridge wasn't sitting on the bearings. Just a couple of photos to show you the actual install. So taking down the sills on the left. Care of to lift the 4 sill units in. Gives you an indication of how close to the track we had to get there with the bridge. So we got that in place and then had to make sure the cab of the truck was in the way of the outriggers. And cranes come in, lift it onto a wagon. Because of axle loadings too, both cranes had to hold weight while they put the weight onto the salmon wagon. They had to take the load themselves and once the load out. Otherwise, they've got the axle loadings approved. And down on site, had to lift it over the parapet of the existing bridge out onto the sill units there. That went in well. This one, essentially, you'll put at the start, shows you right in the middle of the screen there on the left-hand side. That's where the new deck went on. No way of the crane anywhere here. Pontoon potential on the lake there. So that's why they're looking at 2 rail-mounted cranes to get in. Up so there, that set of buildings there is the industrial hamlet, which you'll see in these next photos as well. Another element to this bridge was abutment strengthening. Challenging in the winter.
Just John Lee, just get up into sync with you don't on there.
Okay. On the slides, please. Keep going. Yeah, keep going. You can go forward 1 or 2 more from that. That's all. So for the same structure, at abutment strengthening for both sides, due to program, we had to do this in winter as well, which is working in a watercourse in winter, which has this risk with the high water levels, snow, ice. The EA permit that we got required that we keep 3/4 of the river open at all times, so we weren't allowed to dam it at all. We had issues with high water levels, freezing conditions, restricted working room, so the area that we were up was only about 2 meters wide and only 2.8 meters of headroom. It's difficult to get anything down underneath or any sizes of equipment to do the work. Quite restricted access, saw on that previous slide. Originally we were going to site bash the concrete, where we end up putting about 100 meter state line through industrial hamlet all the way to site. It could change the concrete mix to something with higher early strength and gain a bit of time with it. Whereas this, that we would have had construction joints in. We would have been better to do it quite quick. So this is what it looked like for, so it's these 2 paths on either side here that needed to be button strengthening. You see the stand up just been many headroom there, and that's the Sheaf River and Fairfield. The temporary rescue got involved. It was sandbags, so I had to keep river running. So sandbags, between, then pump that out, and then do one side at a time. Flip it back over to the other side. And sheet piles were installed there as well. So that was another challenge with headroom. Trying to install sheet piles with 2.8 meters headroom. There on the right hand side is a temporary access bridge that was put in across to get from one side to the other. You can lift it out, the river walls come up. It shows where the concrete was pumped through industrial hamlet, through an ironmonger's workshop, back out to the site. Block. Good. So this is what it looked like after. So look quite a little bit. You see that that's now solid concrete, reinforced. Or PSP, or breeze for this one, quite straight from the team of the project, but it was a standard brick construction, inch-flat cavity tile roof. So we did the civils aspect, and then our EMP colleagues come in and did the fit out. You see on the right hand side there. Right before it was the entrance to our site compound. So then we moved our road across. See there, it was fairly smoothly. Only real issue was coming across uncharted services. It's all right now. Dore and Totley station. So it was a new 150 metre long island and a 53 metre extension to the existing platform, and some refurbishment of the existing platform. 2 new lift shafts, which were precast concrete that were brick clad with a metal roof. 2 lift motor rooms and plant rooms, so 1 on each platform. These are block construction with a metal roof all there. Steel bridge to the roof, and 2 steel staircases also to the roof. Key challenges for this was building an island platform between 2 railway lines that were kept open the whole time. So basically, we had to run material on Saturday night possession, and then do the works during the week. Then follow Saturday night on materials out. The existing stadium platform was kept at full operating length and train services. So we did install hoarding to the end of the platform, but couldn't shorten it at all. And signal sighting, there was a signal 56, which needed maintained obscuration for, which you'll see in these coming photos, which proves a bit of a challenge because the obscuration board is right in the middle of our platform where we're building it. So for the new platform going on the right there. See the works there on the top image, and the bottom of is just showing that some of the temporary works that we had to come up with to all the lost there. So we had used the water and concrete pipe through under the track to get out there, so we could do the concreting works during the day, and then a ramp to access out there as well. So the obscuration board I was talking about, see on the left there, that's right in the middle of the footprint of the platform, so we're going to maintain obscuration. So we kept that in place for as long as we could, and then swapped it over to whatever's on the right there, which was attached to the side of the staircase. And then during the project commission, new signal was commissioned, and we could take that one down. Every works that you see there, quite constrained for site. There's the walking up there on the white, so we couldn't go any further that way. So that's why we used the four-sided copper dam to get down there. See the challenges for site constraints. So that's 2-ton digger there used, because these precast units are all about 5 tons each. So you need quite a big machine to lift them in. Quite constrained for space there, and both the road lines on both sides were open at the time. So that was quite challenging. Put an image there of the lift shaft precast being installed. There's more images that show how tight the site was. Just the obscuration boards there right in the middle of the platform again, just in front of the lift shaft. Some photos here showing the steel work installation. So one of the things we did, you see underneath the stairs there, we've got that we're using. So because we wanted the roof to be installed in the factory, we came up with the temporary works design to create beams so that the straps were clear of the cladding, so we could lift it in. Basically all installed apart from where the sections join together. There's access getting up there. It was quite difficult to clad it on site. To show the installation coming in. That's a close up of the beam that we got. So there's two of them per stair section and 2 per footbridge section. And there it is. That was during the 9-day blockade, so not quite finished, but almost. Hand it back to Tom, aka Jamie.
Yeah. And he just needs to move on a couple of slides just on the online presentation as well. That's the final one there. So done. Yeah, a lot of the stuff that Dominic was talking about there looked to be simple, straightforward. It's far from it, because the constraints and the integration with all the other disciplines we had in there. We're not touching that much on signalling, track, all the telecoms and everything that was going on there, but everybody was on top of each other all the time in that area. Now, the main thrust of it was that redoubling coming through Dore and Totley station. So, everybody wanted to be in there at the same time, and that's what constrained the site a bit. So that's what made it challenging from the point of view of not just logistics and integration with the other disciplines, but temporary works as well. We had a lot of hay on temporary works and stakeholders in and around that area as well. So yeah, up next, not Tom, me. So we're going to go through this puppet at the Bamford end of the job. That's on the other side of Totley Tunnel. So Tom's put these slides together for us. I've been through them. I know quite a bit about the scheme, and it's going to take us through on. So let's go through the next slide, please. Just through into some of these. Pick them up. So just click through. See what we. Yeah. No, just go back one if you don't mind. There we go. So if you just leave that one on screen, I'm looking for a little for a moment. Yeah, so dealing with the earthwork cutting at Bamford first. So this a shot you've got there of the before. You can see it's an overly steep, non-compliant, very heavily vegetated cutting that you can see there at the moment. I'll move on a couple of slides. So that's the same as what we view online now. So with badger sets, we were constrained by the TWAO as to how far back we could go into Sixthorn Golf Club. Worthy of note that the guys at Sixthorn were absolutely fantastic with us. The groundskeepers and the greenkeepers there, they couldn't have been more helpful, and the club members as well, they were really good. That could have been a really big problem for us in and around Sticklehome. So yeah, that's what it looked like. It's a soil nail solution that we're going for. So earthwork drawings never look that exciting. There's a cross section through the typical earthwork. So you can see a variance of soil nails there to tie the cutting back with a maintenance berm at sort of mid-height, so that the earthwork inspectors can walk through and take a look at what's going on there. So through to sort of some of these to during. So what we're saying, once you actually go into the job, it's actually less like soil nailing or like rock bolting. From the first slide there, it was very heavily vegetated. As engineers, we always want more GI. Did we have enough GI in this area? Potentially not. We thought it was going to be sort of mantor, heads right the way through, sheer sort of bound rock that we were cutting through, but you can quite clearly see in some of the lower areas there was some rock hard lenses of limestone in there that were very, very difficult to drill. But we maintained the soil nail solution right the way through, but also engaged a consultant from our temporary works designer to almost act as expert witness on our behalf in conversation with the designer, because the CREs on this one, we started to realise, well, I certainly started to realise, some of the things I was looking at were starting to get above my competency level from a geotechnical point of view. So we started bringing people in to help us out on that. So there's another photo there of us carrying the work with a soil nail rig on a long reach machine from the top of the crest. Well, you note as well that we did all of this ALO. So the line was open adjacent to us when we were doing all of this work. It went really, really well. There was a lot of work we needed to do with our colleagues in Volca Rail, because they were managing the ELO process for us. So we put a lot of measures in place to make sure that the track bed that we were clearing at the bottom had the right measures in place. We had the right zones in place, so we weren't encroaching anything. And again, it went without any real significant problems in that area. Yep, moved on to the next slide now. So there's another aerial shot of us sort of midway through the works, give you some idea of how far back we cut that. So what you can see on there is, as well as sort of some temporary works measures on the top of the machine, those little white dots, you can probably guess, they're dump bags for stone. So they acted as the exclusion zone for the machines on the top of the cutting. And across the bottom there, they formed the exclusion zone for the ALO zone. And you can see the big yellow he's just cleaning out the material in that bed. We've got through with the nail at this point, and then working on the backs, we start to put this on the green covering, which is a Matar product, which supposed to go green. One of the things worth noting on here that I did miss out in the introduction, this is obviously in the Dales National Park. So from a planning point of view, there was a lot more constraints on us on this cutting than the one that I'm going to get to later on in the presentation. So yeah, move on to the next couple of slides. So further up from Bamford, the topography of the railway changed. So where we were in a cutting, the golf course, further down behind where we had the compound around Bamford, we're actually just doing some traditional widening. You can see there that first photo is just mentioning to the existing embankment, and the next one moving on, that's one of just as we start to get the embankment covering on, you can see the new track bed with some back tips at the top there. the whole road at the bottom. So on the aerial photo next, that starts to show where the embankments start, the cutting at the top. You see the bottom of the photo there, just the back end of one of our compounds. That bit in there that you can just see in there with the yard, I think that the track guy we're using. Something worthy of note for later on as well, the bit of track that you can see just right hand side of the photo there that's got the red and white barriers on it, that was actually an access road only come to do one of the structures, which I'll come to in a moment. The next slide there just shows our completed embankment. Looks quite tidy. Just going into the tractor. I think that's a relatively recent. We've got there an aerial shot. You can see it's starting to nicely green up now. Got a lot of the fences out, and a lot of that area has now been returned back to Lawn Golf Course. I think in there as well, actually, is that where we actually constructed the new tee box as well? I think did we not? Yeah. Part of the works. You just see there in the top quarter of where we've done the cutting there. It looks quite tidy, really. New track in the bottom there. It's not bad. Another shot there, just a close up of the nails, tied back with the bits. They were a bit of a challenge because the way we had to cut the rock back working from the top, it was very difficult to get a flat area to actually get those base plates to tie back to. So there was some remedial work to actually get them to bed in properly. There was a lot of working at height, a lot of work just to tidy up the wrong way. But yeah, I'm relatively pleased with how that turned out. I think it was a tidy job. Just ignore the key over the moment. We'll come to that one in a second. So we'll move on to the last 25 underbridge. This is probably one of the most challenging bits of the job, and should have been one of the easy ones. So the original design, just leave the slide as it is, thank you, John Lee. The original design, concrete box culvert that was just to extend this bridge back towards us what we're looking at there on that profile. But flowing underneath this bridge, there was a pipeline, Exolium, if I remember the name right. And this pipeline at any time could be carrying the kerosene, diesel, or petrol. I think on the slides here, they say it's run at 50 bar, but I think it actually ran at 80 bar. So one of the big challenges that we had at the start of the job, because there was a sneaky little note on the Form 1 drawing that said that the right was work rail's responsibility to deal with the stakeholder. But once we got into it, it just appeared that we were going to be struggling to actually deliver a Form 1 solution. So we had the option here out what we were doing with this particular stakeholder, and we ended up having to almost drop back right into the grip 4, ES4 at the time design. Again, there's an aerial shot of the bridge, and previously you could see where we put that actual in. And the next slide, that gives you a cross section of what the original design was looking like, and you can see coming through there, there's the profile of this proposed road. And on the next slide, I think if we click through a few, there we go, we get to a photo of this that was coming under the bridge. I can't believe the problem it caused from a point of view of time that actually, delaying the job. If you click on the next slide, this is what was in the AIP drawing. So you can see there that there's where the little red rather is, and the red circle at the top. That was the line of the pipe that was suspected to be correct. It's part of the AIP. And when we went to the survey, you could see where it actually was in relation to the design that we delivered. So we'll click on a few more slides until we get to the cross section of the box culvert. So these are the details that were on the drawing. So the ship clear, you're not putting that over the top of my pipe. From a weight point of view, maintenance point of view, you're not doing it. So then I had to go into a process of not only protecting the pipe, but we had to drop right back into design, as previously said. This is what we came up with. So yeah, it doesn't not like present so well on the page there, but just to take you through it. Effectively, what we've ended up with here is a standard U deck. which straight out the standard design details. We've got two bank seat style abutments with concrete piles, pile. And you'll see again the rakes on those piles on the back ones. We had some significant challenges from proximity of a signal that couldn't be moved as part of the design. Signal is king, sits at the top of the hierarchy, and rightly so. Stops trains crashing into each other. So we couldn't do it to extend the width of the pile caps. We had some significant braking forces because of the goods loophole that we had to overcome. So there's a lot of debate around about what this pile set should look like, how we put them in, we install those raking piles at the back. A lot of chat back to the designer on pile diameter, size, length, so forth. And we were of the opinion that it was not unbuildable, but very, very challenging. All the time as we're going through this as well, clock is ticking on the main contract programme. We're completing the work at Bamford. We're doing culverts, which we were going to come to. Track was actually coming down towards this bridge, and we were leaving an air gap where this bridge was at. We were charging towards the commissioning dates on it. So back to how we installed it. So we had some additional options. Going in with a large 750-ton light boom crane, a mobile crane, but that presented problems because of just logistics of getting it in the little field adjacent to the bridge. So that's TWAO again. So we had two options: either take more land, which meant stepping outside of the Transport and Work Act order. Pete Broom was telling us that just you don't do it, can't do that. It's just too much of a challenge. Or closing the main road, I'll actually rig the crane, because that boom of the crane would encroach back onto the main road to rig it. And the temporary works that would have been involved would have been actually cutting back into the embankment and having to sheet pile the embankment, very close enough. Second was sort of use of about 500-ton crawler, pick and carry, but again, far more onerous to rig. See there again, supply chain I mentioned earlier on. As I flick backwards and forwards through the slides that I've got here, we go to the one that's shown to our colleagues on the online as well. We had a lot of support from Ainscow Crane Iron. Ross Chappell, I think of his name was, Ross. He visited site to us numerous times to try and get the solution to work. And then unfortunately, he never got to deliver it. So you saw earlier on, we actually went with the alternative option of tandem lifting it with the Kirov. We developed this, and I think talking to Kevin Franks from Volta Plant, who runs the Kirovs, is the first time we did it down at TJC 136 that anybody had attempted to tandem lift a bridge in picking using a salmon wagon effectively as a drawbar, which is what we did. So because it worked so well at TJC 136, might as well just do it here again. And if we move on through a couple of slides, I think we've got some photos of it being installed. So yeah, piling, we effectively infilled the bridge, create a piling platform. Van L came in and did the piling for us on this one. I frankly made it look easy. Just installed the piles with very little fuss, in and out, hardly knew they were there. So that went really, really well. And there's the photo again of us installing the bridge in exactly the same way as we did down at TJC 136, tandem lifting with the two Kirovs. So that's installed in the end. What you'll notice, I think, on that slide, you can see, I think, the track is starting to approach, the bridge with that gap left out, just up. Excuse me, sorry, so we've installed the bridge before we moved on. Let's move on, because again, this is in the national park. Planning quite late, incidentally. There was a lot of engagement the team had to planners as to what they would accept, because originally this was a concrete box. It was going to be cladded in stone. We're totally changing the look of it, not just changing the look, we're changing the form of the structure. So through negotiation, or is it engagement? I'm not sure quite what the word is, but we ended up done cladding to the wing walls, and then we capped off with a contic pile wall behind there as well, with a capping beam on the top, forming the wing walls that came away from bank seats, with the existing wing walls in behind them, if that makes sense. So we just bury them in behind, so they became redundant. And then we've got this this cladding natural stone. And so although I was talking about minimum viable product, the walls were the product we could use, the thing we couldn't cheaper, but due to planning constraints, this is what we ended up in this structure. So afterwards, you can see in the photo there, once we've got it all done, you can see the two wing walls on the left-hand side there, and that's the new Bamford passing loop going over the top of it. You can just about make out on this slide, if you've got eagle eyes or good eyesight, you can see that that controlling signal as well for the passing loop just to the east side of the bridge. So that was one of the major constraints that we had to overcome when we were doing the redesign. So if we move on to the next one, we'll get to some final parts of this. So we have three culvert extensions to do that went underneath. Quite big, just precast concrete culverts. If you remember, I was talking earlier on about MVP, minimum viable product. That was one of the culverts it was tying into. So you could see it. That we're able to maintain the drains. But yeah, so there wasn't a lot getting through that one. And you flick onto the next slide. Now, this is the culvert we actually started tying into it. 25A, maybe 24, I'm not sure what it was. Some new culverts, and again, it's tying into something of a very similar size, not that big. A few more, and that's one of the culverts in the bottom there that you can't see. That's what we were aiming at. This is 26. That's done. Yeah. So that was a culvert that we had to install that came in, I think, in 3 bits, and we almost Layout style to come in around a big reception pipe tying into the existing head wall that you can see on the other side. And the next slide shows you, it's quite a neat idea. I like this design at all. I kicked off about it quite a lot when we were going through the process. If you move on to the next slide, you can see what the finished product looks like there. I think the point that I'm making on the culverts is it gets back to the minimum viable product part of it, is that we have left the infrastructure as part of the Port Valley works fit for purpose and future proofed. If Network Rail want to come back at a later date and upgrade that culvert, which is downstream of ours, so we're not creating a problem of venturing the water down or dropping it down. We're upstream, so the water's going to back up in the way. But if Network Rail want to come in and maintain the culvert on the other side, they've got something compliant to tie into. And that was a big challenge convincing the guys on site when they came back with the usual one of wasting money, what we're doing this for, and this is what we're tying into. So that's another one that we have to look. So Hathersage Footbridge, we'll quickly touch on this one. It's become apparent. Tom put in there from the sublime to the ridiculous. Standard bridge that we were putting in there, split level with straightforward pad foundations on either side. This work was to remove a small user crossing for a footpath. You see the lattice work on there, so it was heritage, but the national park as well, so I wanted the bridge to look fitting for the area. So this one again was more location. So got some lovely shots of when it was being installed, because it was absolutely Baltic in the valley there, freezing cold over this weekend when it went in. We installed it over a 44 possession, but again, although we've got a nice big field right next to us, the restrictions of the Transport and Works Act order prevented us from putting any heavy lifting plant in there. So we had to come up with something novel for getting the bridge to its actual location. So you can see in that photo that we've got there before we move on that we've actually got a real mounted mobile crane. It was about a 80 tonner, I think it was, that we got in. And we move on to the next slide. This is actually how we got it there. So using the compound that we had up at Bamford Station, we engaged with Geismar to say, well, could we use your pens? What's the pens? Which way around is it? I was getting mixed. I think they're the pens, aren't they? Whichever, pens and lens, half of them. I think they're the pens. So we could move it down to track, down the track to the actual site location. So we got a temporary works design done by Maybe I think it was, that did the frame that sat on top of the lens there. We loaded it on from the compound and then travelled it down to site. And the next photo, I think, shows why we needed to do this, because we had this overbridge that we had to get under, and it literally just squeezed under. We had a senior engineer, project engineer, who went to work on the Midland Mainline scheme for us, who planned all of this. And we actually laser scanned that bridge, got the CAD details to check that it sailed under there. Of course, we could move it up and down, and we actually had some lateral movement across as well. There's Ian Kilpatrick on the top that said it'll never work. So thankfully he's smiling at that point, which he didn't do very often in the project. So yeah, complex, but really successful to get it in, and a good job on still to be installed. Unfortunately, this part is still ongoing. We had some quality issues with it. So yeah, one bit turned up, still in its primer coat. That's what it looks like at the moment. We had to encapsulate it and repaint parts of it as well. So yeah, that part of it is still ongoing a bit. Right, quickly moving on, very conscious of time, so I'll rattle through this bit, although this is probably what turned into the most challenging part of the project. So myself and Dom will maybe do a little bit of a double team on this one. Moving back down to the Dore and Totley area, we're into the Dore South Curve earthworks. So photo there again shows roughly where the work is. So this is 20 well, that's Westview Lane. The flats that you can see there, just underneath Uncle Stinkbomb the Badger there, that's the sort of some residence flats that I'll refer to in a little while. So we were putting a new loop and some S&C in there to bring the new line through from Dore and Totley Station. So it commenced September 2022. Very awkward site access, TWAO, angry residents that Tom's called them there. I think that's a little bit of an understatement. Sort of badges in there that we had to get various engagements on the licenses, and also that is an ancient woodland that we were right behind us there. So the restrictions that we had on that TWAO order were absolutely crippling to some effect. So the solution on that was supposed to be a soil nailed reinforced cutting, some 934 5 to 11 metre nails. That again is a pretty uninspiring cross section of what the site looks like. But as we get through the next couple of slides, first bucket in the ground, and that's what we found. So wasn't exactly the first bucket in the ground. The first 90 metres or so was as per planned, but the design said that we were going to have relatively stiff firm clays right the way through that just needed stabilised to actually build the embankment slope back up. The original design was that we actually sort of developed a little bit further, actually did call for a spray concrete face on it, but we designed that out. However, what we found on these is some very deep and sort of dodgy counterforts really, because we're full of all sorts of different types of material. I think if you move on to the next slide, just on the line, you'll see some red lines come up just to highlight where those counterforts were found. So as you move through, you can see they're just made up of brick rubble and all sorts. I suspect it was just horizons that had come out of those flats that had been built. So effectively, we were back to the drawing board on this part of the work. So you can see on the overview slide, if you move to the next one. One more, please. Yeah, there we go. That's the bit that we got completed through where Westview flats are, where the white bags start. That's where we really started to hit the geotech problems, and we had to go back to a redesign on there. So there, next slide along. just shows the part that we did get completed, and the first part of the S&C and the passing loop going in there. Then we sort of like broke it down into these sort of 3 sections, and we had almost like, you know, section A, B, and C. C successfully nailed, done, matted, and jobs are good. We thought section A was going to be the easy part, because that we value engineered just to put a 30-degree regrade in, so we actually reduced the nails quite a bit, and then the second part of it was a redesign into section B that we got to. This is the section A that we were talking about. So, you know, with the constraints of how far we could go back into the woods, we were working from track bed level. Just keep clicking through some of these slides. 30-degree slope, simple enough. No, putting out other ideas. That's what happened. We got a sort of some back cracking and some deep-seated rotational failures when we were cutting it back. Now, this all happened, I think 3 weeks before the blockade dawned, didn't it? Yes. Found that. So this almost put the team into proper panic mode, because, you know, we were charging towards this commissioning blockade, and we had to get that track in, unless the whole job wouldn't get commissioned as planned. So, you know, supply chain again to the rescue, engagement with our own permanent works designers and Richter. We got a sheet pile solution in there to actually shore the toe up, so we could then carry on with the blockade, and got a load of monitoring in there. That's being monitored, I think, daily at the moment, isn't it? Just to make sure that we've got no further movement. That part of it is still undergoing design. I think we've got an IDC on it next week to actually get that bit finally released. So this again is part of the works we said earlier on when I said the September 24 is maybe a bit debatable. It's part of the works that we're just starting to look at now. But yeah, I'll catch up with where we're at on the line now. There we go. So this is the section B area I was talking about. So the solution that we actually came up with on here, because the restrictions are where we were at with the ancient woodland behind us, the Transport and Works Act order and so forth, we've actually now got a contig wall pile in there, you know, 660 mil down the piles, 40 metres deep, and there's about 154 of those. So we started it, I think, in about September to put the piles in. I think it was the date. Very, very challenging programme. Everything had to go right on this to get them in. But again, Keller came in and put those in for us. Not Keller, sorry, Van El came in and put those in for us and made that look relatively easy. So move on to the next slide. See them working in there with the rig. Temporary works that we had to put in and to gain access around it, because they were right on the edge of the access platform that we had. I want to move over that one because I don't know why Tom put it in. I didn't take a good look at understanding it, but it's more geotechnical stuff for anybody who's interested in it. And that's what we've ended up with. So we've now got this contig wall that runs the full length, so it's holding and stabilising everything. However, again, next challenge up on the park for us. Part of the design has got a capping beam that ties all the top of those piles together. We haven't got that in yet, so we did the blockade, those piles in. So back to temporary works and temporary works assessment to make sure that those piles would act independently without them being pinned at the top. Just move back one. There we go. Online. So there you go. That's the sort of the stage that we're more or less at now on that part of the work, where we're actually sort of doing that capping beam, so we can complete the works down at Dore South Curve. But the track is in, it's operational, signalling's in, everything's up and running. So we hit that milestone of the commissioning blockade in March this year, which is a massive success for the team, massive success for the whole project. But it hasn't been without its challenges. There endeth the lesson. Steve, I'll hand back to yourself.
Right. Jan, are you able to see if there are any questions coming through?
There's no questions online. I myself am thinking of asking a question. I'm just thinking of what do I ask for now because we've gone through so much stuff. Room first, please.
bit of a whistle stop, wasn't it? I do apologise for that.
Well, I very much enjoyed it. Thank you very much.
Interesting is, as I worked on this project, there was a few things left out, like Hathersage West Footbridge. When you actually look at the Form A drawing on it, it had a single flight of stairs on both sides.
Did.
And then it had a couple of little concrete steps at the bottom.
Did.
So I don't know who did the survey for the Form A, but they obviously got the levels wrong.
Absolutely.
Now, I don't know whether or not it was whether they'd done a LiDAR survey and done it when it was like heavy vegetation, which they thought was the ground levels.
Yeah.
But what we ended up with was effectively one flight of stairs on one side, two flights of stairs on the other side. How did you get that through planning? Because I tried to do a tiny little change to that bridge, and I was told I couldn't do it.
With difficulty.
Yeah.
I think once we got the information, more of the factual information, and we were actually able to demonstrate to the planners. And I think this is where credit really needs to go to the consents team that worked with us, both on Network Rail's side and within the JV. Because once we got that factual information, and then Mark McDonald and Ren and his team from the designers kicked into getting the things actually caddied up properly, it became evident that we couldn't do what was on the AIP. So there was a lot of conversation around what an AIP actually is, which it's you've got an LM footbridge that should sort of suffice, and then with the planning as well and stakeholder engagement with the property on the other side, they were very, very active in wanting to know what the bridge was going to look like, and also what the finish was going to be, and if people could overlook into their property. So it was really just the kicking back into the engagement with the planners and laying things out with them, saying, look, to make something compliant to the standards that we had to work with, this is what we've got. And we laid out what the alternatives were, i.e. an earthworks solution to maybe put some sort of rougher steps, for want of a better word, and a bit of a compound so people could work up to it, or just make it look as if we meant to do it and put that extra flight in and bring it down to ground level. So there was less maintenance in the groundworks around it, which, as we know, can sometimes be neglected in those areas. Yeah. So it was really down to the Pete and the consents team that fully understood what was in the planning to start off with, and also understood where we could get to get the resolution on it.
And get out of interest, did they leave the headroom the same? Because there was talk at one point increasing the headroom.
I think it's been left the same.
Right, that's good, because I had a heck of a battle with the OLE engineers. We tried to keep it as low as possible because of the visual constraints.
And that was right. You're quite right, because that's partly driven as well by the property owners adjacent, because they were very, very concerned about the footbridge being right at the foot of their garden, basically, and they just had this idea that people were going to be stood on the footbridge throwing beer bottles into the garden or things of the like. So
how did you manage to get away with just building a footbridge? Because I believe the whole of the Ripples there just similar, it's really rural.
I don't.
Build up lifts on each side.
Well, interestingly, that came about because Hanson wanted to build a siding into their quarry, and funding became available for an AFA, and that's how it was progressed by the sponsor of that one. So with that being an unmanned station, I think that's where the funding came as part of the AFA process for it. But this is just a foot crossing removal, and the route to the crossing was also not step free, for want of a better word. So you can do that assessment of what the route to it is like. So providing something that was step free wasn't going to add a lot of benefit. It's across a rough field, but
Footpath for the ramp was to get across the track, basically.
It's the same on the Ripples though. On the side, you extract the hillside. So
yeah, I'm
ridiculous.
heavily involved in Hort, so yeah, I understand where.
There's a question online here from Daniel Obetule, who asks, I'd be interested to know how much of an effect the redesign of the earthworks had on project costs. Were costs significantly increased, or were savings made?
Sorry, John Lee, can you just repeat the first part of that, please?
So Daniel Obetule asks, I'd be interested to know how much of an effect the redesign of the earthworks had on project costs. Were they significantly increased or were savings made?
If I deal with two earthwork sections individually, the costs at Bamford were as per tender and budget. Yeah, it took a bit longer to drill, but I think that was just regarded as project risk in that area. But the costs down at Dore and Totley were significantly increased. There's no other way to describe it. I haven't got a figure. I'm not sure if in this forum it's right to actually quote a figure if I had one,
No.
but yeah, they have been significantly increased in that area from the soil nail solution that was originally intended.
I think it's fair to say that the ground conditions that we anticipated were nothing like what we actually encountered.
Yeah.
I was getting daily phone calls about embankment slips in that area, and you can even see where we've got a 30-degree slope there, which should be able to stand up. That was the surface failure on that, didn't you?
Yeah, it's geotechnically in that area. It's taking a lot of understanding, and again, we brought in as Story in the JV. We brought in additional support from another geotechnical engineer to engage from a contractor's perspective with our own designer, because there was at times when I was wanting to be more challenging with the designers on what we were seeing, both from an original solution, because for quite a while they were standing by the design and just saying, we weren't getting a grout return, for example, on flush, so it was just disappearing into the embankment. And at that point, you start to think, well, where's it going? So when we were challenging back, saying this isn't working, and initially we were getting the response, well, it should work, but we said, well, it isn't. So we had to then start bringing in more expertise from our point of view to start engaging on both what was happening on the embankment, on the cutting, and then what the final solution needed to be to answer the geotechnical issues that we were having.
Well, a question in here, yeah.
And again, presumably designed for full electrification at some stage in terms of clearance.
Yes, there is plastic position.
Yeah.
Yes, it's tight. That footbridge, as I say, went in, I think, at 4880. Limited clearance. That was something that we had a real battle with in terms of the OLE engineers, but we needed to keep it down. It had been put in as part of the Transport Works Acts.
Yeah. There's only two overstructures, overbridges on the whole project, and everything else with the provision of track bed. So there's a tunnel as well. Well, there's the tunnel, but yeah, there's
the tunnel clear.
I'm not sure it is.
I don't think it is, but we certainly can go and try it anyway.
No,
but two structures that we built, Hathersage and the AFA footbridge at Dore and Totley.
The other question was, about the really output of all this, as far as passengers concerned, is what is the reduction in timings on the route? Do we know that?
The project does know. Unfortunately, I haven't got those figures off the top of my head.
It is actually quite minimal. The minutes saved is probably only in the region of about 4 or 5 minutes. The problem you have with that is that the savings that you get, you basically get it from the junction at Stockport.
Yeah,
can't remember the name of the junction.
It's on
through to the junction at Dore and Totley. That's where you've made the savings. Problem is that the section from Manchester to Stockport and then the section from Dore and Totley, any savings that you've made there potentially, you might be losing on the other bits there.
So the main gain is capacity on the route.
It's the main gain.
It's the main gain.
Yeah.
Was extensive journey time improvement work done up at the Stockport end, well, right the way through the route, and there was a lot of work done on, I forget the phrase which Steve, on speed, line speed harmonisation, because there's a variance in line speed as you go right the way through the route.
Yeah.
So you've got trains going up and down. So harmonising it through and even reducing line speed in certain areas was considered so that the trains weren't accelerating, braking. So, but again, linking back to the minimum viable product, the amount of work that would needed to be done in culverts, other structures, strengthen them, because once we go through and touch any part of the track, you then have to start looking at all of the crash assessments for the structures that were in there to see if they had the capacity to take whatever ballast or movement was on there, and it just became cost prohibitive as part of the scheme. But it was considered early on in the project.
Sorry, third final question. The island platform, has that got that be used on the mainline side? It's just a blanket end.
It's only single sided. The back side has just got a fence on it. Probably potentially could be modified, but as it is, you could pull a drain up on that side.
Just obviously no way that somebody could get on the travel south to Dore and Totley station, whereas if it had been designed that way, it might allow some trains to move south if they needed to.
Yeah, if you're going from Dore to Chesterfield, you still got to go back to Sheffield.
I know,
Back around.
that's significant disincentive to do it from a commercial point. Thank you very much, Neil.
One thing that Jamie pointed out, and I was quite surprised actually when you showed the extract from Transport Works, because it actually said Hope Valley Project.
Mhm.
And I think 2018 there wasn't actually a Hope Valley project, because the Hope Valley project was made up of about 4 or 5 little projects.
Yeah.
There was the gym site improvement down at Stockport 10, and they all came together to make the Hope Valley job. And I know when the contracts were signed, there was what was it called? There was quite a bit of a gap, if you like, where they had to do some gap analysis in terms of what was in the contract and what we needed to actually do extra over. So almost like from day one when we started the work, we were almost into well, there's not enough money here. There's lots of gaps
value
here.
engineering. Yeah, I think what was trying to get across, because we did have the theme of tonight's presentation as being the challenges that we faced on delivery, and the amount of forehead slapping that the team did collectively when we'd come up with a viable economic option to overcome some of the challenges we found, and we'd have somebody with the book of bad news would open up and say, no, that breaches this part of the TWAO, and right, okay, back to the drawing board. And it did import a significant amount of cost when things started going sideways in certain areas. It was a challenge, and early on in the project, it was a challenge to get people, including myself, to accept that was written in such bold, unmovable text. When we had issues at Bamford, Bamford cutting with the hardness of the rock drilling, we could excavate it, but we couldn't drill it. So I had one of the project engineers just as an academic exercise, if you like, set out what the crest would look like if we cut it back to 30 degrees. So at least we had something to show Network Rails teams, well, we can deliver this a lot quicker for you if you go and buy this land off the golf course. No, wasn't even an option. And we had a similar thing with Dore South curve when we were hitting the geotechnical problems there, to slacken the curve, to slacken the slope off, or even just get more working space to deliver a more economic solution. We just couldn't do it.
Yeah, and I think the other thing that's quite nice to see is at Mass 25, you've actually come up with a solution that I sketched in the meeting and found out where that pipe was going. I sat down with Scott and went, this is what we need to do.
I think we all knew where we were heading.
And there was a certain gentleman from Volker went, no, I'm not doing that. We're going to divert the pipeline. What?
Yeah. Again, the challenges early on in the project, that pipeline caused quite a bit of friction within the teams, because it posed a big problem to delivery, and the owner of the pipeline was hadn't been engaged with properly in the early stages, and was quite clear, well, not on my pipe, matey, you're not covering that over like that. And so fair enough, we have to go and think of something else.
Yeah, I don't think we actually appreciated the importance of that pipeline, because it actually feeds Manchester Airport, is it?
It's and it was very hush.
Oh yeah, it was.
They wouldn't tell you exactly what it was shipping when, but they said it could be anything: diesel, kerosene, petrol.
Well, the other thing as well is if you were actually seen in that field, there was a likelihood that a helicopter would come down and ask you what you're doing. But it was certainly a highly protected asset.
You can imagine the task brief was very detailed for the guys that actually went and did the hand excavations to prove its location.
Well, not only that, they also wanted us to unwrap it, didn't they, as well?
Well, that's where, as a project, we moved away. Thought, well, nobody in an orange jacket has the expertise for messing about with that, so we rightly stepped away from that. That's where, as the JV, we had to go back to Network Rail and say, this is your stakeholder. Don't want to refer to it as a problem, but it was quite clear in the contract documentation that all stakeholder management for the owner of that pipeline was down at Network Rail, and that's where a lot of the discussions were taking place quite early on. It's all coming flooding back.
There's a follow-up question
Yeah.
here online
So,
from
question
Daniel
online, yeah?
Obetulle again. Yeah, Daniel asked. Daniel continues his question by asking, "Did initial GI pick up the issues that you faced?"
The initial GI was heavily supplemented early on in the project, so I think this was another scenario that I've seen on many projects where a cost-effective GI study is done to satisfy the requirements of an AIP, and then an alternative or an enhanced GI spec is then issued to carry out the detailed design. So in the earlier slides that I showed, where we had quite an extensive period between contract award and then the main mobilisation to start in anger on the site around about November, December of the same year, there was quite a lot of mobilisation work and site investigation going on. I think the short answer to the question is yes, it did pick it up, but did we have a sufficient to fully understand it? Hindsight, no. But that's the nature of GI. You can go and drill put yourself a window sample or a borehole in, and you'll get the information out that borehole tells you. Move it 10 yards, particularly in what we were seeing at Bamford, it could be totally different. Because a lot of GI, as you saw from the earthworks slope, was heavily vegetated. It was very steep before we got in there. So it was just impossible to get anywhere near the crest to see what we're dealing with from the material that was being excavated off the slope. So the boreholes in the GI in that area were quite far back, and similarly within Poynton Woods, which is the ancient woodland that we described behind Dore South Curve as well. So as I said at the head of the presentation, he's an engineer ever happy that they've got enough GI. Very, very rarely, particularly after the event, they'll say, "No, at the start, they've got enough to work on from a design." But it's very difficult to say. I think we could have done more in certain areas, certainly a better study on that.
My question, to add to that, my question is, you've used a lot of very large cranes, Kirov 1200s. There aren't very many of them in the country, and they are in high demand. So how did that affect the staging and scheduling of your works?
We had one very lucky sort of ace in our pack on that one. That Volker Rail actually own most of the fleet of Kirovs in the country. So yeah, they go through the usual booking process, but working with like a Kevin Franks, who I mentioned earlier on, Kevin was able to identify early on when those Kirovs, both the 1200s and the 800s, were available. And because of the part of the scheme, it wasn't just on the bridge installations where we used Kirovs, they were extensively used right throughout the whole of the project for S&C delivery and track delivery as well. From a point of view of would we have planned to use the Kirovs for the structural installations? No, we wouldn't. When we planned TJC 136, it was very much out of almost getting to desperation, because we couldn't see any other alternative way to actually get that structure delivered. That was a symptom again of the size that the structure turned out to be. Once we got into detail from AIP, it looked quite a bit smaller than we actually delivered, which may have been able to install by a single Kirov 1200, which we've installed structures like that for. But yeah, the strength of the JV, I think, came into play on that one, with Volker actually having the part of the fleet and the expertise of knowing what their capabilities are.
So there's a question online from an anonymous party who asks, what were the biggest challenges and lessons learned for Story JV on this project?
One, I'll think of one. I think from a story view, to answer the question candidly, what I personally and a story have got out of this is the experience of working on a project of this size in a JV with another supplier, so Volker. I think the relationship that was formed very early on in Volker's understanding what Story's delivery capability was in the sector that we work in. Our contribution to winning the project helped form the JV. But then our working with a supplier with the multidisciplinary capability and the organisational side and capability of Volkers has been a real help. And there's both positive and negatives that we take away from it, but they're all very valuable lessons. So I think that's probably the key one from that I'll take away from on the project. You got anything, Dom?
Potentially the importance of robust planning, because that bridge says didn't get it right the first time around. So it's important to make sure your plans and your temporary works all line up. That things from start to finish. The assumption you make correct, might have.
That's a really good point. So, bit of disclosure on that one. First time we went to install TJC 136, we had a very, very good lift plan in place that myself, Kevin Works, Kevin Franks and Daniel W worked on. We had a very good, robust temporary works design in place for the wrap to get there. But what we didn't do was integrate them very well, and that's what we failed on the night. So we had one very good temporary works design, one really good lift plan, but we hadn't IDC'd them properly. And as engineers, and as my role on another project, that kicked yourself for on that one, and that's something that we've also taken forward into other works. The importance of IDC and temporary works, which is often overlooked, the design deliverable at the end of the day.
The something is the fact that you've delivered a fabulous job, and it's a very difficult job, and fairly important. From a client perspective, and I'm sitting sort of not within the whole Valley team, I'm sitting in the PRU overarching. The sad thing is that I only heard bad news, like from the council, because earthworks was failing here, and it's a shame really that we needed to be singing the praises of this project. Really good project, and I'd have to say that you did a fantastic job in terms of delivering it, because difficult location to actually build anything, and the TWA Act, I think, was also very difficult as well, and fair play to them as well. 2018, putting that together, so I don't think an idea of what they were actually going to do.
We wouldn't have had a Scooby. Yeah, and another thing I'm taking forward onto others. When I hear the TWAO phrase perked up, it's we put extra layer of the thought of looking at this, because it's not just as easy as going, well, we'll get away with something else.
Or factor
Well, we can understand what's in it when you're planning. I think that's the robust planning that Dore was saying comes into play.
Okay, we're approaching 8 o'clock. Thank you very much for the presentation. Excellent.
Pleasure.
A lot of stuff that it was great for me to touch on how you delivered it. And I would just like everybody to show their appreciation to your work. Okay, Jan, I think we close that down now.
Yep. Well, thank you very much for attending this evening seminar by the RCEA. We are now on our summer recess, and we will see you again in September.